This is Dr. Sajja Suneel from Data Science Department. Good morning all. Today I am here to discuss an overview about Introduction to IoT, Physical Devices and Endpoints. What these IoT physical devices and endpoints are. Okay, let's start to discuss about these things in detail. What are the topics which are existed in IoT physical devices and endpoints? Have a look first. We'll enter into the subject, guys. IoT physical devices and endpoints. This was the module which is going to discuss with you about different kinds of physical devices and different kinds of endpoints and how we are going to configure these physical devices and how we are going to maintain the data from the endpoints. All these things are going to be discussed here. Here in this IoT physical devices and endpoints, first we are going to discuss with you about introduction to Arduino and Raspberry Pi. These are the two different types of boards which plays a major role. Arduino is made up of embedded and Raspberry Pi kit is also made up of embedded. But along with Arduino, we are configuring the Arduino board by using Python program as well as microcontroller board it was, where it can understand only zeros and ones. Coming to this particular Raspberry Pi, we are configuring with Python. How the things are going to be happening. Let's have a look. What are the things which I am going to discuss with you in this today's class? First, I am going to tell you about what exactly Arduino was and what exactly Raspberry Pi was, and after that installation procedure, and after that interfaces. What kind of interfaces which are existed, which acts as an interface between these physical devices and endpoints. We require some kind of interface. The interfaces are serial interface, which is UART, SPI interface, and I2C interface. These are the three different kinds of interfaces which we are utilizing. And coming to the next one, programming concept. On this programming, Python programming with Raspberry Pi kit, which we are focusing on the internal, external gadgets and control outputs, as well as reading input from the pins, GPIO pins. Got it, guys? These are the topics which I am going to discuss in today's class. Let's start discussing about what exactly Arduino was and what exactly Raspberry Pi was. First, before starting to discussing about this Arduino and Raspberry Pi, I'll start with discussing about what exactly IoT device was. An IoT device is a physical object which is going to connect to the internet and share data, which is typically contains sensors, actuators, and a network connection, guys. Here we are having some common examples where these devices, which include smart thermostats, wearables, home assistants, and industrial sensors, guys. This is what an IoT device was. Once again I am telling, IoT device is a physical object which is going to connect to the internet and shares the data through it. This is what an IoT device was. What are the key components which are presented in this IoT device? The first thing was sensors. The second thing was actuators. The third thing was network connectivity. And the fourth was processing unit. These are the four different kinds of key components which are existing in an IoT device, guys. Sensors, which are used for collecting the data from the physical world. Actuators, which are going to be controlled physical devices such as motors, lights, valves. These are actuators. And coming to network connectivity, which enables us for communicating with other devices or else other systems. And coming to processing unit, which process the data and perform multiple calculations. These are the key components which are existed in an IoT device. And what are the different kinds of types of IoT devices? I already told you. Here, the types of devices are going to based on some particular criteria. What those criteria are? These devices are going to based on a specific function. Based on function, sensors, actuators, variables. As I told you, sensors are the things which are going to sense the data. Actuators are the things which are going to control the physical devices, right? Variables are the things which are weighed on our body, like our smartwatches, guys. And home automation devices. In home automation devices, smart thermostat, smart lights, smart speakers, whatnot, everything was there in home automation. Coming to industrial IoT devices, sensors, actuators, which are used in manufacturing as well as logistic as well as energy management, guys. These are the different kinds of IoT devices by based on a specific function. The next thing is automotive IoT devices. These are the devices which are used in automobile industries, and like for example connecting cars, right? In every sector our IoT was existed, guys. And based on industry, till now we discussed based on function. Now we are entering into based on industry. In industries, healthcare industry, agriculture industry, retail industry, logistics industry, and energy industry. These are the different kinds of things which our IoT sector was existed. Now based on sizes, microcontroller, I already told you Arduino was the best example for microcontroller, guys. Coming to single board computer, the best example Raspberry Pi kit. And coming to embedded systems, there are n number of devices which are existed which comes under this particular sizes. Single board computers look like your debit card, which is the Raspberry Pi kit, and Arduino board, which looks like this particular pad where multiple transistors, multiple GPIO pins, multiple USB ports which are existed, and I have already shown you that Arduino diagram in my previous class. And the next one is what exactly these IoT physical devices are and what are the endpoints. You need to understand, guys, what IoT physical devices and what endpoints are. IoT physical devices are the tangible objects which are equipped with sensors, actuators through a connectivity which is internet. And coming to endpoints, in IoT context, we refer multiple points like look like terminal points. By using a communication channel, we are going to communicate with these endpoints, right? The key components I already told you: sensors, actuators, microcontrollers, connectivity, power source. All these are going to be called as key components for our IoT physical devices, guys. And what are the examples for these IoT physical devices? Wearables, smartwatches, home automation, smart thermostat, smart lights, all these things. Industrial IoT, equipment of health and production lines, all these things comes under industrial IoT. And coming to automotive, I already told you connected cars, agriculture, soil moisturizer, drone corporate systems, all these things. What are the challenges which we are facing? I already told you by using these physical devices, the challenges such as security, power consumption, data privacy, interoperability, scalability. These are the different kinds of challenges which we are going to face whenever we are utilizing the IoT physical devices, guys. And coming to the considerations, which aspects has to be considered whenever we are using an Arduino board. As you know, it was a open source platform for prototyping and building electronic projects only. We are using this Arduino board for building electronic projects. It is a open source platform for prototyping the things. And coming to Raspberry Pi, it was a credit card sized computer for various kinds of applications which include IoT as well as multiple things. Coming to the next thing, here we are having ESP8266 and ESP32, which comes under Wi-Fi microcontroller with low power consumption. This is the considerations which we have to take care. And coming to the next thing, I will just give you a brief about what exactly this IoT was. We have discussed in multiple classes. Once again, I am letting you know that IoT is a network of physical devices, vehicles, home appliances, as well as different kinds of embedded items with electronics, software, sensors, actuators, and multiple connectivity. And also by using internet connectivity, we are exchanging the informations. I already showed you the components which are used. This was the block diagram for basic IoT device. If you see this particular diagram, you can understand how a basic IoT physical device and endpoints are communicating with each other with the help of the components. See here, this was the cloud and this was the IoT server, and these are the applications which is having a connection with the driver circuit, and that driver circuit is having a connection with IoT board, which is either Arduino or either Raspberry. We can use both, no issue. If I am developing an electronic project where I require an open source prototyping platform, which is Arduino. If I went for software developing, I can use Raspberry Pi kit, right? That is what. See here how cloud and PC terminal are communicating. And for this IT IoT board, power supply is required, as well as which kind of sensor module was using, that has to be noted. And also RF module. These are the basic things which are existed in a small basic IoT device diagram. And the example, you can consider your smart home. In your smart home, there are n number of devices which are existed. Let me take a smart thermostat. How a smart thermostat is going to be utilized. In your smart home, you are having refrigerator, air conditioner, as well as some electrical vehicle, as well as some washing machine, right? For all these four electronic components or automotive components, we require a thermistor as a physical IoT device to gather the data, as well as to to control the physical devices. We require this particular thing called thermistor. What the smart thermistor will do? It is going to predict the temperature, so that automatically AC unit is going to be switched on, which is air conditioning, and next one, water heater. Due to certain temperature, it has to switch on automatically and it has to switch off automatically. Clothes dryer, whenever certain ratio was there, automatically it has to start working process. Whenever it is completed, it has to end it. Electrical vehicle, by using this particular smart thermostat, the things are going to be happen. And coming to the components, temperature sensor, humidity sensor, processor, communication protocols, display, actuator, like this, n number of components are there, guys. And I'll tell you, a sensor was there which is going to predict both temperature as well as humidity, which is DHT22, which is a smart enhancement in this particular sensors. Have a look what kind of architecture layers was there. There are four different layers: application layer, data processing layer, network layer, and sensing layer. These are the four different kinds of layers which are existed in the architectural IoT devices. Have a look. IoT device architecture layers: 1. Application, 2. Data processing, 3. Network layer, 4. Sensing layer. These are the four different kinds of layer which are existed. Once if you observe in application layer, smart watch, smart mobile control operation of our smart home, and a smart gadget and an electronical vehicle, which comes under application layer. Whenever we are entering into the next layer, with the help of this central processing unit and databases, and also a small CPU which is existed in your processing unit, is going to take care of your data processing things. Coming to network layer, it is going to purely take care of the networking like Bluetooth, Wi-Fi, signal, common signal quality through the proper signal station, cloud. All these things comes under here. And coming to sensing layer, we are inputting some sensors like GPS tracker and camera sensors and direction sensors, light sensors, watch sensors, heartbeat sensors, wave sensors, voice sensors. Like this, n number of things can be shown here in these particular sensors. These are the things which comes under sensing layer. Network layer is purely taking care of network. Sensing layer is purely taking care of sensors. Data protection layer is purely taking care of database. And whereas application layer is purely taking care of the physical electronic devices. These are the things which are existed. I already told you these are the layers. And what are the other things which we need to consider was security, power management, data privacy, and scalability. These are the things which we need to additionally consider when we are discussing about these particular IoT architectural layers, guys. And coming to the next one, I will tell you some examples which are related to IoT devices such as smart homes, lights, thermistors, security cameras, wearable devices, smartwatches, fitness trackers, industrial IoT, sensors for machinery, supply chain management, automotive IoT devices, connected cars. These are the some examples of IoT devices, guys. And what now we'll start discussing about Arduino exactly. I'll tell you a small overview about this Arduino. Have a look on the screen once. Arduino, which is a open source platform, which is very easy to use software as well as hardware. Why? Because it is an open source platform for prototyping and mostly it will be used for electronic projects, guys. And coming to microcontroller based, it's purely focused on physical computing only. What are the popular boards? Arduino Uno, Nano, Mega, Linado, and Arduino IDE, which is an integrated development environment for programming. Basic functionalities: digital input by output, analog input by output, pulse width modulation, serial communication, application, robotics, home automation, wearables, and data logging. These are the different kinds of Arduino overviews. And have a look what Arduino was. I already told you it was an open source platform for building electronic components. It is purely deciding with two main components such as Arduino hardware and Arduino software. Coming to Arduino hardware, we are having microcontroller boards and shields with us. Coming to microcontroller boards, there are these are the physical brains. Microcontroller boards are the physical brains of our project, like Arduino, Uno, Nano. Coming to shields, these are the add-on boards, guys, like Wi-Fi, Bluetooth, motor, sensors, etc. And coming to Arduino IDE, I already told you, IDE is like integrated development environment, which is a software based where we are writing the code and by using some specific language called C++. This is for beginners, guys. And why Arduino? It is very easy to use, which is an open source platform, which is having large community and large versatility. And what is the Raspberry Pi? I already told you guys, this was the best enhancement device which is used by us in IoT systems. What this Raspberry Pi was? It was a single board computer. It was more powerful than Arduino. It runs operating system Linux based. Coming to versatile applications, IoT, robotics, media center, education. Hardware specifications: processor, RAM, storage, connectivity. Programming languages: Python, C++, Java, anything can be framed. Example projects: home automation was based on this particular Raspberry Pi only, guys. Have a look what exactly this Raspberry Pi was. I already told you Raspberry looks like a credit card or debit card which is compatible in your hand. Got it, guys? It was a packing surprise amount of power. Why? Because it is purely designed to be affordable and which to be accessible and for making a good choice to us. Where we are designing this Raspberry Pi, learning to code, home automation, media center. These are the things which we are using. What can you do by using Raspberry Pi? By using retro gaming, robotics, IoT projects, web servers. These are the things which are going to be done with the help of Raspberry Pi. And coming to the key features, it was very low cost, small size, versatility, GPIO pins, community. These are the things. And how exactly these Raspberry Pi models are: Raspberry Pi 4, Raspberry Pi B, Raspberry Pi A, Raspberry Pi Zero, Raspberry Pico, like this. N number of models are available in the market. We can choose any kind of Raspberry board as per our project requirement. And what are the different kinds of communication protocols? I already told you there are three different kinds of communication protocols. One is serial, another one is SPI, another one is I2C, and the third one which is related to network, which is wireless communication protocols. Those are wireless, Bluetooth, Zigbee. Coming to the real world applications, there are show divers in IoT projects, showcase drivers like smart agriculture, smart home, smart agriculture, smart healthcare, smart industrial automation, and then smart environmental monitoring. All these things. What are the challenges for future needs? Security, privacy, power consumption, interoperability, scalability, emerging technologies. These are the challenges and these are the future trends, enhancements which can be done in an IoT. And what exactly an IoT device was? IoT device was a physical entity and it is a data generation project and which is limited processing, and these are the best examples for a physical IoT device like smart thermostat, smart wearables, industrial sensors. And coming to endpoint, what an endpoint was? Endpoint will be used for digital representation, data processing, communication. The best example for this endpoint was cloud servers, mobile applications, gateways. These are the best examples I can say. And coming to the next one, what kind of IoT devices can be used in a smart home? Thermostat, smart lights, door locks, security systems. Coming to wearable, smart watches, fitness trackers, health monitors. And coming to the next one, IoT devices used in industry. Temperature sensors, pressure sensors, vibration sensors, motor controls. All these are the different kinds of platforms. Now we will start discussing about endpoints. Cloud platform, AWS, Microsoft Azure, Google Cloud Platform. Coming to mobile applications, smartphone app for controlling the IoT devices, wearable device for companion apps, IoT gateways for devices and networks, data analytics, software for processing and analyzing the IoT data. And these are the roles which we need to fulfill at the time of installation in an IoT cycle. Installation will place a critical phase. Why? Because every IoT device life cycle is going to based on this particular bridge, which is going to bridge the gap between manufacturing and operational stages. What are the key roles which are existed? Physical development, configuration and setup. Physical development deals with the place which we are installing the device. Configuring, how effectively we are configuring that particular device is going to play an important key role. And what are the important efficient communication between these devices and endpoints? First, real-time data transfer, which is required for time-sensitive applications and predictive maintenance. And coming to the next one, which is scalability, where we are utilizing with growing networks, flexible development, reliability, where we are utilizing with continuous types of operations here, and data integrity will also a factor of reliability. And coming to the next thing, which is energy efficiency, where battery powered devices and extended battery powered devices. Coming to security, data protection, data privacy, these are the two factors which plays a major role in our security. And coming to the next one, which is a particular different types of interfaces which are used. I already told you there are different kinds of interfaces: graphical interface, command line interface, menu driven interface like ATM vending machines, command line interfaces like Linux terminal command prompt, graphical user interfaces like our desktop systems, mobile apps. All these things comes under GUI. And coming to the next, user interfaces, there are two different kinds of user interfaces: natural language interface and touch screen interface. Next, hardware interfaces: serial interface, parallel interface, network interface. Serial interfaces are two types: UART, SPI, I2C. And coming to parallel interfaces, USB, Firewire, network interface, Ethernet, Wi-Fi, Bluetooth. And sensor interface, example was ADC, DAC, analog to digital converter, and digital to analog converter, which is going to connect sensors to the system. These are the different kinds of interfaces which we discussed so far. Now we are discussing about software interface, which is application programming interface, API, GUI, graphical user interface, command line interface, and data interference. These are the different types of interfaces. Apart these, there are two different interfaces like brain computing interfaces and human machine interfaces, which connects the brain to a computer, which is brain computer interface. Facilitate interaction between humans and machines, which is human machine interface. These are the three things which are involved. What is serial communication? UART was the serial communication. Basic concept of serial communication was, which is a method of transmitting data one bit at a time over a communication channel. That is what serial communication in IoT was. How it works: data transmission and synchronization, start and stop bits. These are the step by steps which this serial communication is going to function. Finally, parity bit, which is implemented for error checking. Types of serial communication: asynchronous, synchronous. Asynchronous, no clock signal will be used. Synchronous, clock signal is going to be used. Asynchronous, UART only. Synchronous, SPI and I2C both can be used. What are the advantages? It is very cost effective. It will be used for simple implementation, long distance transmission, and low power consumption. These are the different kinds of advantages which are going to be happen. And coming to common serial protocols which are used in IoT. Common serial protocols are UART, SPI, I2C. These are the three different types of things. The best example for common serial protocols are temperature sensor, which can becomes under UART, SPI, which is stands for SPI protocol, master slave protocol. This was a synchronous serial transmission used for short distance communication only. Here, master and slave both pins are going to be there in the architecture. Master is going to be initiated for data transfer. Slave is going to be response to the master commands. And coming to next one, I2C protocol, which is used for purely for addressing the format and addressing the schema. How the data transfer rate is going to be. Have a look here. We are framing with condition, address frame, data transfer, and stop conditions. These are the things which are happening in data transfer. And coming to the differentiation of these particular interfaces, I have specified to you clearly in by comparing with multiple applications. Have a look and it will be useful for you. Why? Because I have specified data transfer, clocking, data rate, number of wires, topology, address, complexity, and use cases in all the three different types of communications. One is UART, which is serial. SPI, it also comes under serial. I2C, it is also comes under serial at the time of data transfer. Only difference was clocking will be synchronous in UART and synchronous in SPI and I2C. Same data rates, have a look. Everything was specified in form of a clear representation of table. This was a table comparison for both UART, SPI and I2C. And coming to the installation consideration, we need to maintain multiple factors like device mounting and placement. Device mounting will place a major role. Why? Because if I place a physical device in a certain direction, then only the data is going to be recorded. If the device where I am fitting that particular device is going to get spoiled after a few days, what is the usage of fixing the device? So, device mounting and placement will place a major role. What are the factors to be considered? The device type and function, which is the main factor which we need to be considered. And also environmental conditions. What temperature it was facing? Is there any humidity? Is there any dust or depths? Is there any electromagnetic interference? Coming to physical constraints, is proper space is available? Is surface type was good or not? Is particular weight and load capacity is going to be maintained at the fixed area or not? All these are comes under physical constraints. Next, ethics. What kind of ethics we are following, whether it is visible or integrated or not. Coming to accessibility, what kind of maintenance and what kind of user interaction we are using. These are the mountaining options: wall mountaining, seal mountaining, pole mountaining, surface mountaining, enclosure mountaining. And coming to placement considerations, sensor placements will place a major role. Why? Because we need to optimize the sensor location. And coming to the next one, actuator placement. Why? Because to ensure a proper alignment and clearance of actuator movement which is required. So gateway placement, where maximum network coverage and signal strength is going to be there. And with this, the placements considerations were very good. Power supply, types of power supply: battery power supply or else physical power supply, line power supply, energy harvesting. All these are the different kinds of power supplies which we are using. What are the factors which are affecting this device power consumption, operation environment, battery life, safety, cost, reliability? These are the different kinds of factors which are affecting on our power supply choice. And what are the environmental factors which has to be considered? What kind of temperature? What kind of humidity? Is there any rainfall? Is there any dust and practicals are there? Is there any kind of electromagnetic interfaces? Is there any kind of vibration or shock which was passing through our device? Coming to the fourth factor, security and privacy consideration. What kind of security? Device authentication, data encryption, security boot, firmware updates, access controls, physical security. All these things comes under security considerations. And what are the privacy considerations which we need to follow? Data has to be minimized, data has to anonymization, consent management, data retention, privacy based design, and transparency. These are the privacy considerations which has to be maintained. And I already told you about this Raspberry Pi kit in detail, and I already told you how it works and what are the different kinds of applications. This was the Raspberry Pi kit, which will be in the form of a board. Have a look here, a most powerful processor. This was the Type C cable, and here these two are the HDMI ports. These two are the USB port 2 and USB port 3, and this was used for gigabyte internet. And the choice of RAM is purely dependent on you. Why? Because as per the project, you guys need to select this particular board, guys. And what are GPIO pins? There are n number of pins, right? In this Raspberry Pi kit, we are having GPIO pins also. I will show you where these GPIO pins are. These are the GPIO pins, which was not mentioned here. GPIO pins, these are called as. And coming to GPIO pins, we are having pulse width modulation. What pulse width modulation was? The purpose of this particular modulation was to control the average power which is delivered to load the power either to on or to switch off. What kind of applications can be used by using power width modulation? Which is controlling LED brightness, motor speed, and other analog purposes. The process and a small example was represented here. You can observe once by keeping pause. And this is about motor control. How the motor is going to be controlled. What are the basic principles which are existed? And have a look. I have clearly specified. And coming to sensor interfacing, analog sensors, digital sensors, I2C PC. These are the different kinds of sensor interfacing concepts which are existed in IoT. Coming to communication protocols which are discussed previously also, I have once more showing you for your better understanding purpose. That's it, guys. We'll meet in the next class by discussing about cloud offering techniques in detail. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.